Right, meeting is recorded. Continue. Okay, all right, great. Well, so this morning I'm gonna do 3 lectures about foot and ankle. So we sort of kick off our foot and ankle core lecture. I'm gonna talk about biomechanics, which is pretty dry, but I'll try to keep it as interactive and as interesting as possible. And then the next lecture is going to be on flat foot, and then we'll end with cavis. So we thought that these are good lectures to kind of group together because a lot of the deformity stuff has to, have to understand the biomechanics. And then it's also, for me personally, it's easier to think of flat foot and cavis as kind of group them together as the opposites of each other. So it's a little bit easier to kind of remember. And then there's going to be questions sort of interspersed on my talk. And, I'll call on someone or someone can jump in and do the questions. And then what we can do is whoever does the question before, they can pick the next person, since I am relatively new and I don't know everyone's names yet. I've only worked with some of the 5s and the 2s who are part of the foot and ankle rotation. So, oh, and then last thing is at the end of each talk, so there's 3 talks, I have these little sort of get to know you questions, since I'm new and I don't know you guys, and you guys, many of you guys do not know me. So just 3 questions, but I'll explain that when we get there. So we'll first talk about the biomechanics of the foot and ankle. Just review kind of the biomechanics of all the joints, as well as review the normal gait cycle. So we'll talk about the ankle joint, the subtalar joint, the transverse tarsal joints, and how they relate in the gait cycle. So basically, when you look at the ankle joint, which is the tibial-talar joint, the anatomic characteristics of this joint are important because it does affect how it works. So we know that the talar dome is wider anteriorly, and so that gives it more stability when the ankle is in dorsiflexion, just because there's more tibial talar contact pressure. And as the ankle kind of goes into this dorsiflex position, the fibula actually has to move laterally. And that makes sense, right? Because the talus is wider, so it's to accommodate that. The axis of rotation of the ankle joint is an oblique axis. So it's this kind of red line that I've drawn here. And the main effect of this oblique axis is essentially that if your leg is sort of stable and we're just, dorsiflexing the ankle and moving your foot up, you'll see in this picture that there's actually, your foot kind of goes out, right? So there's an external rotation, but then when your foot or your ankle is plantar flex, your foot will actually rotate inward. So it's a slightly internal rotation. By the same token, if now we stabilize your foot and fix your foot and your leg is moving with ankle dorsiflexion, you'll see that like this line here or this board here is really your tibia. So you'll actually get some internal rotation of the tibia with ankle dorsiflexion, and then you'll get some external rotation of the tibia when the ankle is plantar flexed. And these are important, when we talk about gait. So the subtalar joint is also a joint that has this oblique axis. So it's this red line that I've drawn here. And the way that the leg moves when the ankle or when the subtalar joint is in inversion, your tibia will actually externally rotate. And then that causes a stiffened hindfoot. So the way I sort of remember this is if you look down at your foot and you kind of like invert your ankle or your subtalar joint, your leg, right, your knee has to move outwards for you to see it. So with inversion, there's this external rotation of the tibia. On the same token, when the subtalar joint is rotation, and this is really important because when you're putting your foot down in a gait cycle, when your heel first hits the ground, you really want your heel and your lower leg to be really soft and supple so you can absorb that impact. So when the subtalar joint is everted, it creates flexibility in the hind foot, and that's really important for gait. Okay, so this takes us to our first question. So who would like to do this question?
I'm Sarah. I'm one of the R2s. I can try to tackle
Hi,
it.
Sarah. Great.
Hi, Dr. Chen. So what is the primary function of the subtalar joint during the early stance phase of normal walking gait on a flat surface? Controls tibial advancement over the talus, locks the transverse tarsal joint to create a stable midfoot, reduces transmission of stresses to the contralateral knee and hip, allows full pelvic rotation while allowing forward foot progression, or converts internal tibial rotation to foot pronation and calcaneal eversion. So in the early stance phase, I think it's like you are shock absorbing.
Correct.
So you want a flexible foot to distribute the stresses. So you would want your subtalar joint in eversion.
You got it.
So let me figure out which of those answers. I think that's probably C, the middle one, because you're absorbing stress to just like in the foot.
Right, but you said, what did you say? You said you want your subtalar joint to be
Everted. So then
everted,
the final
right?
answer.
And then if you were looking at C, it reduces transmission of stresses to the contralateral knee and hip, right?
Got it.
That's not the contralateral, right? So
right.
So what else do you think?
So then answer choice E has calcaneal eversion and foot pronation, which we want.
That is correct. Okay, yeah, exactly. So you said it. You just, kind of, I think this kind of, reduces transmission. This was a good test question, right? Because they tricked you. Yeah, so, oh, and by the way, these questions are from Andrew. So thank you for him for doing that. All right, so Sarah, you're going to call the next person. Okay, so as we, whoever does the question, they're going to call the next one. Okay, so we'll move on to muscle position and function. So this is a really basic concept. I know you guys understand this, but I just feel like it's important to repeat it. But basically, the function of every muscle and tendon, the function of it really depends on where it crosses the joints, right? So either the subtalar joint, which is this this pink line, or the ankle joint. So if it crosses behind the ankle joint, it's obviously going to be a plantar flexor. If it crosses medial to the subtalar joint axis, it's going to be an inverter. So your tibial tendon, which is really important in walking and propulsion and gait, it crosses right here, right? So that's, that makes it a plantar flexion because it's behind the ankle axis, and then it's medial to the subtalar axis. So that's going to cause the foot to also invert when the subtalar, or when the posterior tib tendon is pulling. The other thing is that the amount of force that's generated by these tendons and muscles is really dependent on how large the muscle is, which totally makes sense, and also the moment arm from the actual axis. So the further away it is, the more force there is. So the Achilles tendon, which is going to insert back here, this is going to be the furthest away from the ankle. That's going to produce a more powerful force. Okay, so next question. Sarah, you call someone.
I think we should call in Musa.
Great.
So normal functioning posterior tibialis tendon is best confirmed by which of the following physical exam findings: pronation of the foot during stance phase of gait, heel inversion at the beginning of a single limb heel rise, active inversion of the non-weight bearing foot, active plantar flexion of the first rate against resistance, active plantar flexion of the foot during push off gait. It's I'm gonna go for number 2.
You got it. Yep. Because when normal functioning, right? So what is it? Basically, it's just asking you, what does the posterior tendon do? So causes heel inversion. So, all right. So when we talk about your hind foot motion, we often say these words like supination and pronation. We all know what they mean. But what's important to understand is that when we say this particular word, supination and inversion, it's actually a combination of 3 joints that are working together. It's your subtalar joint, and it's your transverse tarsal joints. So the transverse tarsal joints are basically the the talar navicular joint and the calcaneocuboid. So all of these joints work together to give you supination. So supination involves an inversion of the hind foot, but it also, if you think about it, if you're like supinating, there is a little bit of plantar flexion that also happens. And then there's a little bit of adduction that happens in the hind foot. Pronation, on the other hand, is a little bit of eversion, a little bit of dorsiflexion, right? As you're kind of turning your foot up, and then a little bit of abduction. The calcaneocuboid and talar-navicular joints, as I mentioned, are what we call the transverse tarsal joints. Oftentimes, these are also referred to as Chopard's joints. So the position of these joints in relation to your subtalar joint is critically important in understanding gait. And this is often tested upon in every single OIT, definitely on the boards. So what the most important thing to understand is when your subtalar joint is in this everted position, which we had previously talked about, your foot is actually very supple. And so when the subtalar I have in green is everted, your Chopard joints, which is the CC and the TN, they're parallel to each other. So basically they're not locked. They're very supple. They can absorb pressure. And this is what happens when your heel first hits the ground, because you want it to be very smooth and fluid, flexible hind foot to kind of absorb the motion. But when you push off, which is where you're trying to take the next step and push your whole body into the next step, you don't want this to be really flexible anymore. You want it to be really rigid and locked. So in this location, in this position, your subtalar joint is going to go into inversion. That's because of the posterior tib tendon kind of pulling. But when that happens, it locks the talar navicular and the CC joint, as in this picture here. So once they're locked, it becomes a really rigid hind foot. And then that way your Achilles can really kind of contract and really push you off into the next step. Okay, Musa, who's the next person that's going to do this question?
I'm going to pick Andrew Figoni, who's actually sitting next to me.
Great.
So which of the following best describes the relationship of the subtalar joint and the transverse tarsal joint during the phases of gait? So let's see, we want them locked for a rigid lever as you're going through toe off. So number 5 is wrong.
Mm-hmm.
If they're parallel during heel strike.
Yep, they're parallel during heel strike, which is good, right? Because when they're parallel, it means that it's a flexible hind foot.
Yeah.
So what's your answer?
I think it's 2.
That's correct. Yep, exactly. I mean, this question is basically, asking you which one of these is correct, right? So if you look at number 1, eversion of the subtalar joint, eversion of the subtalar joint locks, that's not true, right? It's inversion. Inversion locks it. So we said the transverse tarsal joints are parallel during heel strike. That's true. They're parallel, so it's a supple joint. And it says number 3, the calcaneus is an inversion throughout the stance phase. It's not true, right? If it's an inversion, it's like always rigid. You don't want it to be always rigid, because when you're first hitting the ground, that's the start of stance phase. It should be supple. Tibialis anterior contracts, concentrically contracts during the stance phase. So actually it eccentrically contracts, so that's not true. And then number 5, during push off, the foot becomes flexible due to, well, it's not flexible, right? So you can say right there, because during push off, you want it to be rigid. So number 2 is the answer. Okay. Yeah, so I'm repeating this point over and over. So again, here's the same concept. So supple foot, right? So what does that mean? So that is when your foot really just hits the ground. That's the very first moment your heel touches the ground. Your ankle, if you think about it in your head, is coarse and dorsiflexion. Your TN and your CC joints are parallel because it's supple. And then your subtalar joint is in eversion. And then by that token, your tibial is rotated, internally rotated. So when you kind of, go through the gait cycle when from the heel touching the ground and then rolling through, and now you're kind of getting ready to push off with like toe or heel off and toe off. You want it to be really rigid. So in this position, your ankle is actually in plantar flexion because you're getting ready to kind of push off. Your CC and your TN are now divergent and they're locked. So you want everything to be stiff, and your subtalar joint is an inversion and then external rotation of your tibia. So Andrew, who's the next person who's going to answer this question?
Let's go with Avi.
Ding, ding, ding.
Which of the following structures is the primary site of force transfer between the hindfoot and forefoot during the stance phase of gait? Plantar aponeurosis, the Achilles tendon, Lisfranc ligament, posterior tibial tendon, anterior tibial tendon. I think for transfer from the hindfoot to the forefoot, it would be a structure that crosses them. So plantar aponeurosis.
Yes, exactly. Yeah, we didn't touch upon that, but I think most people understand this one. Okay, was it Avi?
Yeah.
I just did the last question.
Yeah, is that me, Avi?
Okay, so you call on someone else. We got another question, 2 questions in a row.
Great. How about Jen?
Jen.
Okay. So what is the role of the posterior tibial tendon during the gait cycle? Invert the heel and lock the transverse tarsal joint to create a stiff lever for which to initiate heel rise. Invert the heel and lock the transverse tarsal joint to create a flexible midfoot. Evert the heel and lock the transverse tarsal joint to create a stiff lever which to initiate heel rise. Or evert the heel and unlock the transverse tarsal joint to create a flexible midfoot with which to accommodate heel strike. I think we're creating a stiff lever, and I think it will be the second choice, invert the heel, unlock the transverse tarsal joint. Oh no, wait, sorry, the first choice, invert the heel to create a stiff lever.
Yep, exactly. Yep, inverts the heel and then creates a stiff lever. That is correct. Okay, so normal gait. So gait is basically a bipedal mode of mobility for human beings. And the goals of your gait is obviously to move you around, but also it's to expend the least amount of energy and also to put the minimal, the smallest amount of stress on your bones and joints and muscles. So a normal walking or gait cycle is divided into the stance phase and then the swing phase. So the stance phase really begins when your heel, say on your right foot, hits the ground. So it's the heel strike, and then kind of your foot goes flat, and then your heel rise and toe off. So that's the whole portion of stance phase. During stance phase, what happens is that your leg has to accept the body weight, right? So so initially we talked about, when the heel's hitting the ground, you want it to be a very supple hind foot to kind of absorb the impact. But then during swing phase, that starts with toe off. So your leg kind of swings forward to the next step. During this gait cycles, we spend about 60% in stance phase. So 60% of the time your right foot is touching the ground, and then about 40% of the time your right leg is kind of swinging forward. And the percentage of time that you spend in each of these stance phase or swing phase is based upon how fast you're going, your velocity. So if you're running, you're going to have a smaller stance phase. So these are again, the two phases of the gait cycle, but then I did put for the stance phase, I wrote down the 4 different phases. So you can see with stance phases begins with a heel strike, and then kind of you're slowly lowering down your foot. So that's the foot flat portion. And during this portion, your anterior tib is actually very slowly controlling that. So that's why it's an eccentric contracture. It's not a concentric, like one of the questions or answers to the other questions. And then you get to foot flat, and then that's when suddenly now your post tib is going to start firing and kind of make that hind foot really rigid. And your heel is going to come off the ground, and then your Achilles and your gastroc soleus are going to start firing, and then you're going to go push off, and that kind of propels you into the next step. And then the swing phase is your foot essentially kind of just swinging through. Okay, Jen, who will answer this question?
How about Sachin?
Okay, so the question is, which of the following does not occur during the normal push-off stance of the gait cycle? So number one is subtalar joint inversion. Number two is transverse tarsal joint locks. Three is external rotation of the lower extremity. Four is tightening of the plantar fascia. And five is loosening of the spring ligament. So thinking about push-off, we want a rigid foot. So the subtalar joint does invert, which locks the transverse tarsal joints. So number 1 and 2, I would rule out. I'm pushing off on the ground right now. My plantar fascia feels pretty tight, so I think it's not 4. And then external rotation of the lower extremity. Well, we said that if when we evert, our tibia externally rotates, and so we're not everting here. So I'm gonna guess 3.
So okay, so it's between 3 and 5, right?
Yeah.
So what do you guys know what's the spring ligament? So the spring ligament is the calcaneonavicular ligament, right? So it's this thing. It's important for gait, right? So it's all part of. We'll talk about it in the flat foot section. So pretty much we want, when your post tib fires, everything in the hind foot through the arch, you want it to be really tight. So this is one ligament that you do not want to be loose, because if you're loose, then the midfoot kind of will be very flexible. So so you want this to be tight. So definitely, so the answer here is number 5, because we're not wanting, we don't want the spring ligament to be loose. We want it to be tight. And then so when you're walking, when you're kind of pushing off your, that's a plantar flexion. So you're externally rotating your tibia, if you remember. These are just, you have to sort of remember these things, but the answer is number 5. So definitely don't want the spring ligament to be loose. You want everything to be like super rigid during the push off. Okay. Was it Musa? You did the last one, right?
No, it was Sachin, sorry.
Sachin, sorry. Okay.
No, not a problem.
All right. So Sachin, pick someone else for this question.
Okay. I will pick Ryan Freshman.
All right, so figures 1 through 3 are the MRI images of an abnormal tendon that is most important during which stages of the gait cycle.
Oh, so let me show you this picture, right? So it's saying shows images of abnormal tendon is most important. So this is a two-stage question. This is the hard question. So first you have to determine what tendon are they talking about, and then you have to determine I forget what actually the question was, but let's look at this MRI here. So what's problematic here?
Yeah, so looking at this, at kind of the middle and right hand pictures, looks like there's some fluid around what looks to be the posterior tib tendon.
That's correct. Yep. So if you look here in this one, this is posterior tib, right? Tom, Dick, and Harry. So very nervous, Harry, right? So there's the posterior tib right here. On this view, where is it? It's not here. On this view, where is it? It's not here, right? But, and this is your FDL. So the post tib is not here. So they're showing you, they want you to recognize, okay, no posterior tib. So let's go back to the question.
We can see your mouse when you're pointing.
Oh yeah. Oh no, it's good. Yeah, I want you to see it.
Oh, we
Ah.
can't see it.
You're unable to see it.
Oh, you're unable to see it.
Like, you
Oh,
can
okay.
mark
Okay.
it instead.
Yes, yes, I can. Hold on. Let me get a laser pointer. Can you see this?
Yeah.
Yes, now we can see
Okay.
it.
Yeah.
Going back to that. Yeah, thank
Yeah.
you.
So right here, right? So the posterior tib, FDL, neurovascular bundle, FHL, right? So in this picture, where is it? It's not here. There is the FDL. This is not the posterior tib. This is the FDL. FDL. So no posterior tib.
So thinking about the stage of the gait cycle that's most important, toe off, terminal swing, heel strike, mid stance, and terminal stance. So I believe it is going to be it's not going to be your heel strike.
Sorry.
It's not going to be toe off, but based on the fact that I saw the answer to the question, I'm going to
Oh, sorry. So what did you say it was?
say terminal stance.
That's right. Yeah. So the posterior tib, right? I mean, what it does is that once it fires, it creates a really rigid hind foot, right? And that's getting your foot ready so that the Achilles and the gastroc and soleus can really start to fire. And that is usually at the end of stance, right? Just ready when you're getting ready to push off. So correct. So terminal stance. Okay, so during the swing phase, not a whole lot happens in this phase of the gait cycle. So this is where your hip and your knees are in flexion to kind of, bring up your foot, and then your ankles and dorsiflexion. So here's where your anterior tib actually concentrically contracts. Your long toe flexors are working to kind of hold those toes up, and then you essentially, all of these things are to clear the foot as it swings and clear the ground, but there's otherwise no other muscle activity. So during running, I didn't see a question on this, but I thought it was interesting. But during running, and this is where the velocity of your mobility is faster, you have a decreased stance phase because you're spending less time with kind of the foot on the ground. And then during running, you don't really have a period where you have both feet on the ground. You have a period of what we call the float, right? So you're watching someone running slow, in slow motion. There will be a short period of time where both feet are off the ground. So you have this new phase called the float phase, and then the swing phase and the float phase, and then your foot kind of hits the ground. So that's it for biomechanics of the foot and ankle. And I went through a ton of questions, and really these are kind of the questions that a lot of the OITs and self-assessment tests asked about, which is really just kind of that stiffness of the hind foot and the importance of the posterior tib function.